Hello, ladies and gentlemen, and welcome to episode 22 of Decoding AI in Healthcare. I'm Hetvi Shah, your host, and I'm thrilled to have you all join for an insightful exploration into today's topic of evaluation and validation of large multimodal models in medicine. And today we have an esteemed guest with us. So let me introduce to Dr. Sandeep Reddy, who he has over 25 years of experience in the healthcare sector, boasting a strong background in healthcare management, digital health analysis, and translational medicine. He's currently a professor and head of discipline at Queensland University of Technology and also chairs the non-profit Center for Advancement and Translational AI in Medicine. So, welcome, Dr. Sandeep. It is a pleasure to have you.
It's my pleasure too.
And next, we have Dr. Amit Kumar, a visionary in medical innovation and AI entrepreneurship, bridging the gap between technology and healthcare. Dr. Amit's expertise will provide us with deep insights into the critical data elements necessary for AI success in healthcare. So, welcome, Dr. Amit.
Thank you very much, Hetvi. A warm welcome to one and all to the 22nd episode of our Med AI podcast, Decoding AI in Healthcare. And I'm really happy to host dear friend Dr. Sandeep Reddy from Australia with us. And Sandeep has been working very closely in spreading AI literacy in his country and across other parts of the globe. And he has also been working strongly on establishing certain kinds of a framework by which we can evaluate and we can validate the generative AI large language model. So, dear friends, we've come a long way in our podcast with various topics, and we now have a reach of over 60 countries with this podcast. And we get a diverse population of healthcare providers joining us live every time. And then, of course, you get to see the replay and the recast on YouTube and the MedSynapse platform as well. So, today, over the next 1 hour, dear friends, we're going to talk about large language models. And the biggest question that comes to our mind when we are using a general purpose LLM or a generative AI model is it valid? Is it evaluated? And is it right for the use in medicine and healthcare? So, the key question to ask is how do we evaluate and validate these models? Well, at one point, you have the technical evaluation and the technical validation, which forms one wing. And the other end, we also have the clinical validation. So, how can we have a mix of both? And who would be the person that states doing that? These are some of the questions that we will try to answer today. So, welcome, Sandeep, to the Med AI podcast. It's great to have you.
It's a pleasure, Amit.
So, Sandeep, I'll start with the first idea from you so that our audience and our viewers get a clear understanding that we've been working on with artificial intelligence for many years now. It's not new. And we had the traditional AI models, the machine learnings, the deep learning algorithms. But then again, there has been the evolution of generative AI, and that has largely come with natural language processing and with these huge foundation data set driven large language models. So, in the context of healthcare applications, how are these traditional AI models different from the generative AI models and large language models that we are dealing with at present?
That's a very interesting question, Amit. If you look at the evolution of AI, as you rightly stated, it's been around for a while. And even in medicine, we have a long-standing history of use of AI. But if you go back decades ago, we commenced use of AI in medicine with the use of expert systems. And expert systems were those which had explicit rule-based algorithms. And they were very good when you focused on small data, but when you looked at complex data and a huge amount of data, these expert systems weren't very useful. And then there was emergence of neural networks or deep learning based models. And they were very good in being able to analyze huge amount of complex data But then we had the issue with those deep learning models as the lack of explainability, which we'll talk further into the podcast. But to address your question about what's the difference between the newer models that have come and fall under the guise or the umbrella of generative AI and the previous models, is that I would call them as discriminative AI. And what they would do is basically they were very good in categorizing and classifying data based on patterns or based on being able to predict. In medicine, it would be being able to predict a differential diagnosis. So they were not generating new data. They basically were analyzing or inferring any solutions out of existing data. What has happened is with the rise of generative AI still utilizes existing data for its training, but the difference is it actually synthesizes or generates new data. That's the key difference. And that's the novelty part of generative AI. And large language models falls under that generative AI classification.
Yes. So now, when we are looking to use generative AI, something that generates synthetic data over and beyond the discriminative, the extraction part that it was already doing, and we are looking to apply that in healthcare to give us clinical guidance, to give us certain predictive analytics, we really need to set up a framework by which these models can actually be evaluated and validated, and there would come the answer or the question of explainability. Because we understand this very well that without explainability, it is very difficult to use an AI model in the domain of healthcare. So, Sandeep, we were very impressed, and I personally read your entire paper that you published, which discusses on the framework of the translational value for assessment of the language models. So, could you tell us about this paper? Could you tell us about the key components of this framework that you highlighted about, and how do you really feel that an LLM should be evaluated in the context of healthcare?
So the rationale or the reason why I developed that paper was that there's a lot of natural language processing based metrics or large language model based technical metrics looking for consistency, looking for the relevance, looking for the accuracy. And nowadays we are using benchmarks or assessment metrics like massive multi-language understanding MMLUs, and in the healthcare context, GP questions and answering. And then there is math frameworks. In the past, we use Rogue, Blue, and so forth. So there's evolution of technical metrics as the large language models get more complex and get closer to the reasoning capabilities of human beings. You obviously have evolution of technical metrics. But that's completely fine to assess the technical metrics. But if you look at the healthcare context, there's much more to what we do with AI in the healthcare, and the implications are much more serious. So from that point of view, I felt like we really need to, from a healthcare point of view or a medical point of view, have additional assessment frameworks. This is not so much to hinder the progress of AI, is to ensure that whatever AI models we use, large language models, or now with the ability of AI to do multimodal analysis, multimodal AI, that we ensure they are safe and of a high quality and have real clinical improvements coming out of it. So from that point of view, I propose this framework. So it's like an onion with layers. So internally in the core, you have the technical metrics, the NLP metrics, which we talked about. And then outer layer or the middle layer, we have the translational aspects where we assess the utility, capability, and the adoption of AI, mainly looking at the internal validation, external validation, but also looking at how what are the clinical implications of that particular model, but also looking at the explainability and all of those things. And then there is the outer layer, which often gets ignored, is what are the ethical ramifications? What are the ethical implications of the use of this AI? And if people dismiss that, you think about the possibilities of AI introducing discrimination, having biases, and lack of explainability, as you rightly talked about. It was very important in healthcare, but also looking at the medical legal ramifications of use of AI. And when things go all right, who becomes responsible? So basically, from that point of view, it's a comprehensive framework. And what it does in healthcare is ensures that when you start to use AI models, whether it's large language models or multimodal AI or large vision models, that they are safe and they do have a clinical relevance when you use it in healthcare.
Yeah, very right. And I think that there has to be layers of explainability, not just one layer. There has to be layers of explainability when we are evaluating and validating. Now, since 2022, since the launch of OpenAI and ChatGPT, I think there has been a huge use case of using GPTs, the Geminis, the Llamas, whatever has come in healthcare. But deep inside, Sandeep, we know that these are general purpose large language models, and we are still lacking a proper, structured, standardized medical LLM that can be used for a larger purpose. I mean, MedPalm has developed, but not still not for a large scale use to most parts of the world. And of course, there is MedLama. Things a lot of things are probably evolving, and maybe on the Hugging Face leaderboard, we would find newer language models coming up every day. But having said that, the larger use cases are usually with these general purpose language models, and people are using it in healthcare, thick and thin. So, from your perspective, where you're setting up a framework of evaluating and validating a language model, how do you see these general purpose LLMs being used? And what are the significant challenges that you find that these general purpose LLMs would bring when they would be applied in the context of language model in the context of healthcare? Having said that, a lot of evolution has happened. GPT has gone from 3.5 to 4.0. Hallucination is much less. A larger foundation data set it's being trained upon. But still, what are the challenges that we see?
Yeah, I really get annoyed when people assess general purpose map models in papers and say, look, this falls short of what we expect in
Yes.
medical context.
Yeah.
And I think about an analogy would be bringing in a teacher is probably equipped to teach students, but is probably not having that particular specialty. Say you want that particular teacher to teach into maths. Maybe the teacher could do some, level of teaching, but not at the level of what you would expect from a specialized maths teacher. From that point of view, you do raise a very important point: is to be able to fine tune the general purpose models to a medical context. And there are various ways to do that. There's the fine tuning approach where you particularly change some of the weights, or you train that model on a specific domain. And then there is the other process called RAG and LoRa, where you link up the general purpose model with an external data set and be able to arrive at a much more conclusive answer. So there's ways to do that. So there's some progress in that area. In fact, there are a couple of open source medical large language models. The famous one is Meditron, developed by researchers from Yale University. And they have also been able to offer it globally so that they are able to receive feedback from various practitioners from across the world. But you're right. We are still very early days in terms of being able to have specialized medical models. And now with the emergence of multimodal models, I think it becomes all the more important to have something that is suited to the medical domain. But I like the notion of multimodal models because the way clinicians work is we utilize not just text data. We utilize data from laboratory sources, from medical imaging, and while speaking to the patient, but also using medical equipment to derive audio data. So from that point of view, I like the notion of having multimodal AI models as opposed to just large language models or just large vision models. So from that point of view, I think there will be more and more as years progress and months progress, specialized models. But it's really important as evaluators that you don't take a general purpose model or a large language model that hasn't been trained on a medical domain and assess it for its medical reasoning or its medical outputs. The earlier framework which we talked about is completely fine to use for specialized large language models or specialized multimodal models. Still, the same assessment criteria stand because you're still talking about the outcomes and the outputs of a model as opposed to the actual inner workings, testing the inner engineering or the inner workings of a model. From that point of view, what we discussed earlier in the previous question and answer is completely fine to be used in a specialized generative AI model.
Yeah, as more and more evolution happens, and I completely agree with you when you mention about the RAGs coming in, and I think even there's going to be a lot of evolution coming with the language models, and we always talk about the large language model, but there are also some good use cases of using a medium or a small language model that someone can develop, which can be very specific, uh, narrow use case to a particular context and use in healthcare, which might be much more superior than using a larger foundation model dataset language model. So we will see all these evolution happening in the field of generative AI, but then they need to be evaluated and validated. Now, you have good you have good metrics like you already mentioned, and you can just highlight those metrics once again for our viewers to understand. One end, you have these technical metrics, and you will find a lot of research paper on the technology journals about how you can evaluate a language model based on these technical metrics. But what about clinical metrics? What about having the right clinical framework and the right clinical validation of these language model as and how these develop? So what are your thoughts on that? The technical metrics versus the clinical metrics.
Yeah, before we get to that, Amit, I wanted to talk about that point you raised about small language models, large language models. This is pretty important for us to be able to talk about because when we look at large language models, it requires enormous amount of data, and that's why it's called large language model, because the amount of data that gets involved in training those models is huge. And the second reason why it's called large language models is because of the number of parameters. And we're talking about trillions of parameters as GPT models evolve. And what it means from a user point of view or from a non-engineering point of view is that that whole decision-making process is opaque to the user. How it arrives at, why it hallucinates, and we'll talk about what hallucination means shortly. But all of those things become alien and incomprehensible to the external user. And this is a risk with those large language models. The third reason why, again, these large language models are a potential risk is because they require huge amount of computing infrastructure. And now there's a race for GPUs across the globe and who acquires the maximum number of GPUs so that they can train their large language models. And this is out of reach for small to medium enterprises in developed countries, but in developing countries, it becomes all the more hard to acquire those kind of computing infrastructure. So from that point of view, small language models which require less computing resources, less amount of data, and perhaps more fine-tuned to that particular domain, like medical domain, become all the more relevant. And there have been some studies and papers that have shown that small language models can, in particular situations, perform at the level of large language models. I do have certain ideas as to whether we should be going on the route of large language models and acquiring more data and building more complex models, as opposed to looking at other approaches to progress towards AGI. But that's out of scope of this today's discussion. So that's what I wanted to talk about the thing. But from a clinical point of view, yes, there's the technical metrics, but how does those technical metrics apply to a clinical situation? I think if we think broadly what those technical metrics are trying to achieve, one is they're looking at consistency of the responses of those large language models, looking at the accuracy of the responses of the large language models, they're looking at the relevance of the large language models. Those aspects, those features still apply in a clinical domain. So, for example, you're a diabetologist or endocrinologist, and you would want to know whether the model that is offered to you actually is able to identify the particular treatment pathways for a type 2 diabetic patient or a person who has diabetic complications. So from that point of view, the relevance of their answers, whether it's giving you the right medication or the right therapeutic pathways, whether it is identifying the particular features in that particular patient, and it's giving a personalized treatment plan. All those things still apply. I think that's completely fine. It's just that you have to, whatever you get metrics, they had to be customized to that particular domain. So, for example, what makes sense in your case, endocrinology, may not make sense in the case of gastroenterology or in nephrology. So, they have to be fine-tuned. But the broad underlying principles like relevance, consistency, and accuracy still apply.
The other aspect, Sandeep, is if you see some of the papers, certain validators have tried to create certain metrics based on the MCQs of the USMLE or the AIMS and the national entrance examinations of India and the other countries based on that. But then we understand that evaluation is a constant process and it is a dynamic process. And also, it's also very important that if a model is evaluated by the end user, then the adoption is also going to be higher by the end user because they are involved in the evaluation and the validation. So on this context, Sandeep, with the dynamism of the data and a time series data, real-time data, which is far, far away from the clinical trial data, the real-world evidence and the difference between the clinical trial, we know that in medicine. How important is human expert validation and evaluation of a model like this, especially in the context of medicine and healthcare?
So with ChatGPT or GPT-4 and GPT-5, which hasn't been released, I understand, but they're working on it. With all these GPTs, what they have is something called reinforcement learning by human feedback. And it applies even for models released by other competitors to OpenAI, like Anthropic, model of Cloud, and Google's Gemini. What they use is a process called reinforcement learning by human feedback. So they train the model and it gives particular prompts, but they want to make sure that particular prompts aligns with the real world answers, the actual facts. And that's where they bring in human beings or human assessors to look at the prompts and retrain or enable the large language model to give accurate prompts. So that already occurs to an extent. But you're right, we really need to engage with users and users. So there's two benefits that come out of it. One is you ensure that particular model is more accurate. The second thing is the adoption of AI models is very poor in healthcare. When you get clinician engagement, patient engagement, that also paves the pathway for AI models. So from that point of view, absolutely, it becomes imperative. If you go back to that governance layer, which we talked about earlier in that assessment framework, translational assessment framework of generative AI or large language models. So one of the important features in that governance layer is to engage with the end user very early on. It's not just at the very end for assessment. post the development of the model, but during the post deployment, but during the development of the model. For example, we talk about data governance panels or clinical governance panels where we have representatives from the target community and also clinicians who not only are briefed about how the model is developed, but also have a say on as to what kind of data is being used to train the model. And you may say, is this important? Yes, very important, because data is really the key or the magic behind AI models. If you use spurious data or you use inaccurate data, no wonder you get inaccurate responses, garbage in, garbage out. So it's very important to have that ability to ensure that accurate data, but also representative data is used in the training of models. In that, it avoids biases, but also in a clinical sense, it also ensures that there is clinically accurate answers. So you can get user engagement very early on to have that human involvement. The other aspect to having human involvement is, in a clinical sense, we always need to ensure that there is human oversight or a clinician oversight, especially in the clinical environment where AI models are being used for as clinical decision support systems or clinical recommendations. There always has to be a human oversight, because even to date, with all the research going into large language models, they still hallucinate. They still provide inaccurate information. And this is a major risk in the clinical environment because it could lead to misinformation, but potentially could lead to risky situations where it could lead to adverse events and even fatalities. So we have to be very careful in relying totally on AI models. And that's where the human oversight or human in the loop, it becomes very important. So from that point of view, you should have human engagement, not just at the end, at the assessment level and post-deployment level, but very early on. But when the model gets deployed in a clinical environment, there is always a level of human oversight that happens.
I think that kind of just relates to what we do in other aspects of medical science, the real world evidence and the studies that we do. And I think that is actually a need of the hour, especially for our friends who are trying to develop a language model, fine tune it, add the layer of reinforcement learning, and before it's deployed into the right use case with the right certification, I think there has to be a layer of human evaluation and human validation coming in. But I would still say we're still short of establishing a standardization to this. Perhaps I think that is still lacking. Maybe more research is required. What would be a standardized model of having a human expert evaluate such that there is the right human in the right loop of evaluating the AI model as and how it develops before it is even deployed. So with that, it brings to another aspect. I mean, a related aspect to this is accountability. And I was reading your paper which mentions about the need of a governance layer to ensure this accountability. And we understand, and this is a common question that I guess both of us face from clinicians, that look, I'm going to use a clinical decision support system. And suppose this goes wrong, who is accountable? Am I accountable for it? Is the system accountable for it? Is the AI accountable for it? Is the maker of the AI accountable for it? Who is responsible for the wrong decision given by the AI language model? So in this context, with all the limitations that we see coming out of a large language model's application in healthcare in terms of its biases, transparency, privacy effect, data security, how can this accountability segment be ensured along with the evaluation and the validation process, especially with the human in the loop?
Yeah, so accountability is a sort of broad term, but I suppose here we are specifically talking about the medical legal aspects.
Yes.
When things go awry or their liability arises. So this is pretty important in terms of AI adoption. If you don't have a proper medical legal framework or accountability framework, if you so will, it becomes a major challenge for clinicians to utilize AI, because if something would go wrong and if they were to be held accountable, and we already talked about how these models have hidden opaque layers and have billions of parameters, trillions of parameters, and they hallucinate. So there is a significant chance of things going wrong. Even if, as days progress and AI models evolve and become much more reliable, there's still a possibility of things going wrong. So at that point of time, a clinician has to be confident that with all the efforts they put from a clinical point of view and they've used the best judgment, that they shouldn't be held responsible for something that the AI model has provided as misinformation or has led to a particular adverse event. So I think from that point of view, it is a imperative on health services, policymakers, governments, and legal authorities to be able to establish an accountability framework or medical legal framework. But we do have already have precedents in medicine. What we call is vicarious responsibility.
Vicarious responsibilities.
Yes, we have that. But also when we utilize medical devices and other kind of medical software, we do have some sort of medical legal framework already existent in hospitals. Depending on the healthcare system, there is nuances to it. But generally, there is some sort of medical legal framework where it says that if things were to go wrong, depending upon what the situation is, it could be the manufacturer or the vendor, or it could be the hospital. But I think it's really it depends upon the situation, and if there is a human led error, rather than going on the route of blaming and finding the trying to point out fingers at somebody, there has to be an open transparent process. But in our paper, we suggested a particular novel framework or a novel setup where there is an ability for the hospital to have a compensation pool or a liability claim process where the blame is not pointed on a particular individual. Because if you were to point out the blame on the vendors, then the vendors become very cagey and become they would not try to innovate or want to develop AI products. So you can't unfairly blame the vendor every time things go wrong. What if the vendors or the product itself was not an issue? It was a human induced error. So would you want to still blame the vendor or the developer? So we wanted to avoid that. Neither did we want to place the blame on the hospital, because then if that's the case, if every time things go wrong, the hospital or health service becomes responsible, then any hospital or health service would be very, very reluctant to adopt AI models. And then if you want to blame the physician or the clinician who's using the AI, then obviously they wouldn't want to use it. So we didn't want that situation to arise. So to avoid all that, we talked about this compensation pool or a process where obviously there is that open, transparent process in trying to find where the issue was and to avoid future emergence or future recurrence of that particular issue. But also if the patient had to be compensated, that compensation pool could cover that. I think this is an evolving field. A lot of legal minds who are better placed to be able to devise this framework are working on that. But our paper, which the government's paper, when we released, there was nothing of this sort of progress in this area. There was very, very the discussion was very infantile and was really very early days. So from that point of view, it was pioneering of our paper to discuss this approach. But I think it's really important to be able to have something that is ready to go, even if it's not perfect, something that is available right now, because a lot of health services are seeking to adopt AI models, but they're not sure what they could do with it. They could go with what is already existent in terms of medical software. But remember, we're talking about AI, which has a possibility in, if not right now, in maybe a couple of years from now, achieving that level of cognitive reasoning and perhaps even sentience as many years progress, it's very different from what you're dealing with other kind of passive technologies that are prevalent today.
It's going to be very, very dynamic. And I quite like the way you said that it has to be transparent at every level. And I think that's where layers of evaluation comes in. There should be continuous evaluation and continuous validation happening even after deployment, even post deployment. There's something like a post marketing surveillance kind of an evaluation happening or a validation happening. So I think those structures it's very important that standing today as we see more and more use cases of language models getting into clinical decision support system. I think these structures need to be set down. And it's also important that there has to be a good amount of adequate voicing from the medical fraternity in how these structures should be set down and how these evaluation and validations must happen. So it's quite an interesting points did come out from the paper that you mentioned. Moving on, Sandeep, let's look at some of the positives. And you did mention about some of the newer language models which are available in the open source and which can be fine tuned into a medical LLM. So could you give us an idea, having a vivid experience of researching on this, could you give us an idea of some of the success stories where you could see a right use case of an LLM being evolved with evaluation and validation and then implemented successfully into a clinical decision support system?
I think it's early days to actually outline examples where large language models have been successfully integrated into clinical workflows. People are still trying to work out the use case scenarios of large language models, but also how they can integrate into existing electronic health records, so to speak, or even act as shadow IT or second screens on their desktops. So there's a lot of work to be done, but we do know existing electronic health records have already integrated large language models into their setup so that it provides chart summarization, but also discharge notes and so forth. And as I mentioned before we started recording, we talked about how here in Australia, in the state where we live in, they've advertised for a external provider to help with medical coding using AI. I think that's a brilliant scenario where AI can be useful because that's a process which is routine and which is lesser risk compared to a clinical scenario, but requires a lot of effort. So from that point of view, it's an evolving space. It's very organic. But the possibilities are immense from that point of view. Personally, the other organization or business that I'm involved with, we developed something called AI Doctor. What it does is basically, if not completely replacing what a primary care physician does in terms of triaging and screening, does pretty much all of those things what you would expect at a very basic level, like conversing with the patient, transcribing the conversation, then being able to extract key points from that and creating a medical note and even a referral letter if that is required, but also extracting CPT codes in the US, but here in Australia, necessary Medicare reimbursement codes and so forth from that notes. But also what it can do is be able to analyze any lab reports and any medical images from a basic point of view. So it's not a software that can replace any primary care physician, but what I feel the possibility of using that in a setting where there is no health service or no healthcare provider, we are aware of that, having trained in remote and rural locations in India, that in certain locations we don't have any clinicians there. So from that point of view, even something like this, which could do an element of triaging and referral, becomes useful, we have developed that, and that we use a large language model. The other scenario where we use a large language model is that business. We developed a training system for doctors in patient communication, especially in tricky situations like palliative care and those kind of end of life situations where doctors are generally not very trained in the medical school about how to converse with patients. So this particular application, what we did was we had an anthropomorphic avatar, which not only would be able to converse with the trainee doctor, but would also be able to recognize the emotions on the trainee doctor. So it's quite advanced, not just passively talking with the doctor, but could also recognize whether the particular doctor was using the right kind of emotions in conversing and be able to then provide that feedback. Underpinning that was a large language model, which was fine tuned to that particular scenario, but we had also an avatar, human looking like avatar that would be able to give that human element to that large language model, but also to be able to recognize the emotions. So there's quite a couple of scenarios, but generally speaking, generative AI, I see promise as medicine starts to become more personalized and
Yes.
utilize genomic data and those kind of specific personal health related data of that particular patient, being able to use this generative AI or multimodal AI to offer that personalized treatment medicine. You could say that couldn't we do that already? But yes, if you think of large volumes of patient and the amount of information that has to be processed and our limited capacity from a human brain point of view, I think the multimodal AI, generative AI offers if not a better feature, a viable option to consider. Also, generative AI has been used to create synthetic data, which is really important in medical AI because we know that even though we have huge amount of data that is available in medicine and in healthcare, a large part of the data is either is not being able to utilize because health services do not want to offer that for training AI because of privacy reasons and whatnot all. But also a large part of the data is unusable from a training point of view. So there are various reasons why we can't use the data. From that point of view, being able to use the synthetic data to train medical AI models also becomes important. So generative AI can do that. We already talked about chart summarization, discharge summaries, extraction of medical codes. So the other aspect that I do as an academic is I use AI to be able to summarize information from papers. I have to go through about nearly 50, 60 papers every week that relate to AI in healthcare. Humanly, to be able to go through all the papers within a week, considering my other commitments, would be really impossible. So from that point of view, using AI to be able to extract information and summarize that information, but direct me to a particular paper that can be novel and useful for my research. It's also another thing that we are using in generative AI. So the possibilities are really growing, and as to how we can use generative AI. Yeah.
Yeah, I guess sky's the limit for using generative AI. And we all understand the potential. And with that, we also understand the possibilities and the limitations and the harm that it can bring. And we all believe that in the medicine, the first rule is do no harm. So we have to ensure that this potential tool that we are going to be using as an adjunct part of augmented intelligence, as we call it, must be evaluated properly and validated. Let me add another context to this. Now, we all understand that when we talk about evaluation and validation, Sandeep, we mostly talk about evaluating and validating the output. But what about the input, the data set on which the model needs to be trained? The diversity of the medical data, different parts of the world would have a different diverse set of data. But as of now, most of the medical LLMs that you see, which are available on open source, are being trained on a siloed set of data. So that is still a limitation factor mostly. or it's usually a fine tuning of a larger foundation model of a general purpose LLM. So, how important it is to not just validate and evaluate the output, but also to evaluate the data set which is being put in to actually train these transformer models and foundation models. What are your thoughts on that?
You raise a very important point. So people who are outside to the AI practitioner community or who are not aware of the process that goes behind training and developing AI models or machine learning models do not understand the importance of data or the data curation or data pre-processing. In fact, the highest amount of effort in developing machine learning models is not so much in figuring out which algorithmic model or which algorithm you want to use. It's about how you can process the data that it is good enough to train the machine learning model. So we know that even though with all the buzz and hype around AI, we still have to train a machine learning model, and there's a lot of work that goes behind it. And the large proportion of that work is in curating the data. So here is why it's so important to ensure from a healthcare perspective that we use the right data is because when we use inaccurate non-representative data, it's not only the risk of biases being introduced, it also it can lead to actual clinical implications or clinical risks. So it's really important to ensure the data that you source is not only representative of the target population where you want to deploy the AI model, but is also free of biases. So that can be overcome by ensuring the data is, if you are deploying an AI model in India, you ensure that the data that you use to train the AI model is sourced from India. Because we have seen in the past where AI models that have been developed overseas in developed nations and Western nations being deployed in developing countries, and where they haven't achieved the same level of success as they have achieved in the source countries. So that's largely because, again, they haven't really trained the model or localized the model. And that's an issue. So one of the things that happens with AI models in a clinical situation when you have inaccurate data, or you have, when we talked about general purpose models just being used in medical domain, is that it can lead to misinformation. And this becomes very important when you can directly access those AI models. Pretty much anybody in the globe who has access to internet can access ChatGPT. And if you start to use it to as a personal doctor and rely on it, there's a high degree of risk around that things could go awry, because we know that AI models can hallucinate. Earlier in the podcast, we talked about hallucination, and we thought we'll talk about it. So, what is hallucination? Hallucination is when large language models or generative AI very confidently give you inaccurate information, and it is presented in a manner it looks like it is a fact. And because the way it confidently presents that, you could potentially assume that it is true and it is a fact. And people have gone with it and have been caught with their pants down. So, from that point of view, it's really important to ensure that the data that we use to train models is not only is factual, but is also credible. But also post that, when the model gets deployed into a medical situation or a medical domain, it is fine-tuned, or it has that RAG process where it goes through that customization to that particular domain.
Very nice inputs. I think that was really an insightful thought coming from you, Sandeep. So let's say for a AI entrepreneur, a health tech entrepreneur, starting to explore to take an open source model, fine tune it for a specific use case. Where do they start from in terms of evaluation and validating their model? What are the key steps they should follow? What are your tips?
Yeah, so I'm speaking generally from machine learning point of view, and there are obviously nuances and particular processes that are involved with generative AI. So just let's look at a machine learning point of view. So as I mentioned earlier, the very important part of that machine learning model development is data. Ensure that the data that you acquire is representative of that particular domain. Say, for example, you are developing a diabetes detection model or a model that is used to recommend particular modalities of treatment for diabetes type 2. Ensure that you get necessary data that can help with that rather than source general data and try to figure out something with the model. So data acquisition is really a challenge for entrepreneurs, because if you approach health services, they're not normally very reluctant to hand over the data. But if you work with them and you are able to explain to them that you're going to be able to not only look at commercialization of the model, but also to be able to support their clinical processes, maybe they will be much more open to that. But also in the UK and in other countries, there are provisions where you can get anonymized data, de-identified data for training your models. And there's also public data sets that you can acquire, which are very well curated. There is the famous Mimic data set, but there are also medical imaging data sets that you can acquire, which are well curated and of credible nature that you can utilize. So from that point of view, it starts at the very beginning, the way you acquire or where you acquire the data. Following that, if you did have the resources involving clinicians and your end users like patients in a data governance panel, becomes depending on your resources, is going to be a really an attractive feature, because what it does is it not only gives you that input as to where you can focus your energy on in terms of the model outputs, but also it enables the adoption of AI because you're involving representatives of the target community. So the next part is ensuring that you use the right algorithmic model. And I don't want to get too technical into this process, but when you get complex data, it's advisable to use neural networks or more advanced machine learning models, because your classical machine learning models are incapable of being able to analyze complex data. But on the hand, if you have some small data sets and it's not very complex, the attraction of using classical machine learning models or your traditional machine learning models is they are explainable. So here we probably have to devote a little bit of time on what explainability is and why it's important in medicine. So we know that as clinical practitioners, when we approach a particular medical situation, that we use causal reasoning, we use our medical training, we also refer to resources. And then when we are questioned about why we are using a particular treatment, we have an ability to be able to respond to that. But with deep learning models, with those complex machine learning models, because of the hidden layers or the deep layers that are existent within that algorithmic model, we are unable to understand how the decision was arrived at. We can approximate the decision was arrived at. There are explainable frameworks like Shapley values, Lime frameworks, and ICE, and so forth. But that's also an approximation. What we don't really understand is exact nature of the way the decision was arrived at. You may say, why is that important? We know that we are using drugs, which we don't know the pharmacokinetics, pharmacodynamics. That's completely a different situation. I find that analogy a bit irksome, because it's not the way what we would be expecting of AI models. AI models adopt a different process, but also have a much more a superior role in the way we use AI, because they are actually replacing or augmenting the role of doctors. So it's a different analogy. So from that point of view, we do need to have some level of explainability. Unfortunately, even to date, there isn't an exact or a perfect process in which we can understand the decision-making process. We can approximate how it has arrived at, and people are working on that as we speak. So from that point of the simple machine learning models like decision tree models, random forest, linear regression, they're completely inherently explainable. They're called intrinsically interpretable models. and they work very well. We in our one of our projects, we used a decision tree model, and it worked very much more better than neural network models. But the data set was quite small. So, if you do use complex and advanced machine learning models, ensure that you have some sort of a level of explainability, not so much explaining the technical aspects, but explaining how the decision was arrived at, which features were important in arriving the decision. So, that's another part of the evaluation assessment process. And then when you do have the model ready, ensure you not only have internal validation, you also have external validation. So what is external validation? So internal validation means looking at the accuracy and the curve, your F1 score, your precision and accuracy and all of those metrics. But external validation is taking the model and actually testing it on an independent data set. So that is very rare. In fact, you can count on your fingers very few instances where external validation, it's growing, but it is very small in numbers. Most of the models or most of the papers you see are all internally validated. So external validation really becomes important. It goes back to that example where you talked about, Amit, is how do we ensure that the models that are developed elsewhere are locally successful? That's why external validation really helps. So a layer, but overall, in summary, aside from technical metrics, ensure that you have taken into consideration the clinical implications of the model and also the ethical implications and the medical legal implications. This is very important. This often gets ignored by technical people of technical background, but it's so important in medicine to consider.
And just to add to that, the end, just add that layer of human evaluation and human
Yes.
validation before deployment. I think that is so very important because that is what is going to bridge the gap from the technology world into the clinical world and improve that adoption and
Yes.
the usability of that particular model, the whole purpose with which you're probably building the model. But I think you've given a very vivid outlay, and I think this is going to be helping a lot of our AI entrepreneurs, and I'm sure there are a lot of medical graduates who are now exploring this avenue of being an AI entrepreneur, building products, trying to commercialize them and bring them out in the market. So I think this evaluation and validation is going to play a key role in its adoption and the way it is looked upon by the generation of clinicians to come. So we had a fantastic discussion so far, and we're almost at the end of this 1 hour of podcast. So before we let you go, Sandeep, and we will also come in with some questions from Hethi, but before that, what do you see the future holds for these language models evolving in the field of healthcare and medicine? And do you really see some newer metrics coming up that can be specifically used to test, validate the medical use case language models?
So, from a future point of view, I'm very optimistic and excited about multimodal AI. And we discussed why that is so, because multimodal AI is more of representative of how clinicians work in real world, and large language models just process text, and large vision models just process vision data. But if you look at multimodal data, they can not only process text, they can also process audio data, but also vision models. So that's one area where I'm really excited about how it pans out. But the other area where I'm really excited and I'm working currently is something we call as AI agents. So we know that with this large language models, what we do is we enter a prompt and it provides an output. It's very passive in the process. But with agentic workflow or agentic action is that they go multiple steps beyond that. They not only have that ability to get that prompts, but also to act upon it in the real world. I'll give an example, a non-medical example. If I have an AI agent as my AI assistant, I just ask it what's my schedule and plan for the day. what it do is look into my calendar, look at what appointments I have, ensure it sends an email to that attendees and participants, confirms their availability. But if there was a requirement for me to have called somebody or to call somebody, actually makes that call and even confirms that appointment is still there. And if necessary, if I have to travel, book an Uber and also possibly even book a flight ticket. So you can start to see that it's much more than what current large language models can offer. And I think that if you extrapolate that to the medical domain, you can start to see an ability of a doctor to use an agent, maybe not completely replace their functions, but to take away their administrative work. If they had to schedule a appointment with their patients, or a patient had to schedule appointment with them, it's able to take a charge of that administrative functions and give more time for the clinician to be able to focus on the clinical tasks. So those areas I'm really excited and interested about you. Sorry, what is this latter part of your question that you
Any
asked?
newer metrics? Any newer metrics that you are seeing evolving? For evaluating these medical language models.
Yes, I think if we start to look more and more AI agents being deployed into if not the clinical environment, general real world environment, I think there has to be a different level of metrics that are to be assessed. That I think because it's a field that is still in its very early stage, I haven't seen specific metrics come around that, but there will be certainly metrics being developed to assess that agentic actions.
I think the agents are going to be really something very exciting in the domain of medicine. But again, you need to really have it validated and evaluated such that it only does what it needs to do and doesn't do more than what it has been trained to do, because that's where it should not be creating the harm. So again, their fine tuning, their validation and evaluation is going to play such a key role. So fantastic discussion there, Sandeep, and we had collected a lot of good insights, and I think this is still an evolving space. Even 6 months back, we were not talking about these evaluation tools and validation metrics so confidently as we are doing today. And perhaps as we see in the next 6 months, maybe we can have another podcast discussing this in a much more confident way and probably have more newer metrics that can help our clinician friends and our researcher friends and AI entrepreneur friends build the right kind of use case models based out of their generative AI language models or AI agents or whatever they have at hand. So, Hetvi, do we have any questions from the audience? I guess we always get a live audience joining in here. So, if there is any questions from the audience side, Hetvi?
Yes, we do have a.
Yeah, we can take one before we let Sandeep go.
Okay, sure. Thank you, Dr. Sandeep, for sharing your insights with us. So please allow a question. So the question says, with the rapid evolution of AI in healthcare, how important is continuous education and training for healthcare professionals and effectively leveraging these technologies?
Yeah, so very important. Now, literacy is going to be the key when we talk about validation and evaluation, because the literacy rate has to increase amongst clinicians on the AI knowledge. Your thoughts, Sandeep?
Yeah, so really goes to how many of us use AI. If you think about the percentage of the globe that uses uses internet is 67%. And pretty much whoever uses the internet is using AI, whether we're using emails, whether we're using watching streaming services, whether we are using booking flights. AI is already there. From that point of view, we have a significant proportion of the population of the earth using AI. And if we don't know this technology, as unlike any other technology that we have seen in the past, or unlike any other thing we have seen in the past, and if you look at the rapid progress around AI, and we're talking about seeing AGI within the decade or in a couple of years, it becomes very risky if we don't know what AI is. So it becomes really imperative on the stakeholders to educate the general community about AI. That's talking about general AI. But then when we look at AI in medicine, it's really risky of medical schools and healthcare institutions not to train their current students or current trainees around AI. Why is that so? Because when these medical students graduate or these healthcare professionals go into real world clinical practice, they're going to be surrounded by AI enabled technology. And here you are never been exposed to AI and you don't know what AI, the implications of use of AI. And then suddenly you are asked to use this AI enabled medical software or AI-enabled medical device. So I think it's really imperative for schools, medical institutions, to be able to have inclusion of not just AI, medical informatics as a discipline, as a subject, very early on. And I think it's important, not just here in Australia, but all across the world, in India and any part of the world, to ensure that there is a significant effort that goes into training healthcare professionals. So that's medical students, but also healthcare professionals, whether it's doctors or nurses, there still has to be an opportunity for them to be able to access some level of training and introduction to AI. They don't have to become machine learning engineers. They don't have to become data scientists. They just have to know enough that they have confidence when they encounter or they start to use AI. What are the ramifications of using that? What are the benefits of that? What are the limitations of that? Such that they are much more confident, but also it also enables the better adoption of AI and the safe use of AI.
And I think on that note, we have an immediate workshop coming up right tomorrow. That's on the MedSynapse platform. We conduct a 6 hours of marathon workshop. It's a hands-on training of how you can get started with AI to increase your daily productivity as a clinician. It's tailor-made for doctors. So that's coming up, AI Workshop 3.0. So you guys can find the link to that on the MedSynapse platform as well as on our LinkedIn Connects. And I guess, Hetvi, the registration link is still open. So if anybody is interested to register and join us tomorrow, that's 4 p.m. to 9 p.m. on India Standard Time. So on this note, once again, I thank Sandeep for joining us today. We had an insightful session on evaluation and validation of the generative AI language models. And I guess this topic that we need to keep discussing and raise our voice on, because that's how we can actually find the right effective and safe and transparent use of this language model into our clinical practice. Sandeep, once again, thank you very much for joining in. Hetvi, I will hand it back to you. And also to tell our audience that the next podcast coming up, I guess, at the end of this month is going to be a very interesting one. My co-host Deepu Patel is going to be hosting that with a very young guest who is very enthusiastic about building AI models for the healthcare community. So stay tuned and stay updated. Over to you, Ed.
Yes, thank you, Dr. Amit. We'll soon publish the update for the next podcast as well. And as of today, as we conclude today's episode, I want to extend my heartfelt thanks to our distinguished speakers, Dr. Sandeep Reddy and our host, Dr. Amit. Your deep insights and practical perspectives on this topic have been truly enlightening. And I also want to express my appreciation to our engaged audience. Your thoughtful questions and active participation have made this session even more enriching. So until next time, stay curious, stay connected, and we'll see you in the next episode. Goodbye. Thank you.